Parts of polynomial functions. In this tutorial, we are going to see the parts of polynomial functions. So let's see the general form of polynomial functions. General form of polynomial function. Let it be p of x is a function or polynomial functions. So this is a general expression: an x to the power of n plus an minus 1 x to the power of n minus 1. This doesn't necessarily or it's not telling you that the leading coefficient is the same as the exponent of polynomial function. Okay, so an minus 2 x to the power of n minus 2 plus this will continue. As you can see, the exponent is decreasing from n to n minus 1 and minus 2, and then finally it goes to plus a 2x to the power of 2. This is just, we don't know the value of a1, we don't know the value of a2, a3, just to represent the coefficient, plus a1 x to the power of 1. We don't have to write 1 here. Okay, let it be 1 plus n odd x to the power of 0. Okay, so let's see the part. Let's see what is going on here. Okay, let me draw the line to see the parts. Okay, let's have this one. Okay, so that clearly we can see all the parts. Let me see here. Okay, so let's see. First, as you can see here, polynomial function is the sum of monomials. As you can see, these all are monomials, and the monomial is the product of, in this case, as you can see here, the coefficient, which is the number, and the variable x. Okay, so let's see the coefficient. In this case, we have a coefficient. We have the coefficient. Okay, coefficient. So in this case, like an minus 1. Okay, or let's n minus 1, an minus 2, an minus 3, and so on. So you have there finally a1 and a naught. Okay, when we see the coefficient here, this could be just to give you examples, just to visualize. This could be root 2, okay, but this could be 1, this could be minus 1, I don't know, just any number, It could be, sometimes let's even use pi, because it's just a number. Okay, so as you can see here, we have rational, we have irrational. Therefore, the coefficient could be elements of a real number. Okay, let it be an is elements of real number. Okay, the coefficient could be any number. Now we have c here n, like this one. We have n minus 1, we have n minus 2, and finally we have 2, 1, and 0. Okay, these are called the degree, okay, or order, or the degrees. Okay, these are called degrees or order, or order of the polynomial function. In what order that polynomial function represent? Okay, but usually we call it degrees. Okay, but when we see this one, as you can see here, all of them, it's getting decreasing, right? It's getting decreasing. Therefore, this one is the largest. Okay, on the expression, n is called the leading, or the degree of. Okay, but the degree of, we have only one degree, but we have a lot of degrees. But the degree, or that function, is represented, or in general, the degree, when we talk about the degree of polynomial function, we are not talking about the degrees of each term. Okay, these are the degrees of each term, but the degree of the polynomial function, the degree of p of x, okay, is n. So the largest degree is the degree of that polynomial function, or the order of that polynomial functions. Okay, but this all still are degrees of, okay, degrees of terms or monomials. Okay, mono means single. So each term, these are the degree of each terms, including, but that one is the largest one is the degree. Okay, so always the degree n should be an element of positive integer. Okay, positive. We can't have a negative exponent, we can't have a rational exponent. So this is the coefficient, degree. Now let's see the constant term. Of course, it is part of the coefficient. Let it be. Anyway, it's constant term. We do have a constant term. It's not necessary, of course. Depends on the coefficient, the polynomial functions. But in this case, this a naught, the last one. Okay, the constant term is term independent of the indeterminate, or we can say variables. The variables. Okay, indeterminate is when I say indeterminate, x, it doesn't depend on anything else. It stands by itself. Okay, so variables. Okay, so in this case a naught is a constant. Okay, in this case a naught is a constant, but it's not always. I mean, the polynomial function may or may have, we have a real life phenomenon or situation where constant is not involved. For example, I can say this is a polynomial function. Okay, this is a polynomial function. Maybe I can say p of x is equals to x squared. This is polynomial functions. Okay, maybe this is a polynomial function. Look at this one. X cubed. This is by the way, this is just this is a square. The first one is a square. Okay, I can say this is a square. The second one could represent a cube. Okay, it could represent a cube whose dimension is x units. Okay, I can say it's a cube whose dimension, we can represent x cubed as a cube. Okay, as a cube. This one is x, this one is x, this one is x. So this could represent the volume of something. Therefore, these are the parts that you need to or we need to understand.